This is Wicked Al, and I'm here with Bob Simpson, founder, and Steve Tice, co-founder of EVDrive. This is what's going to go into the Wicked Al race quad, and I'd like Bob to go ahead and talk a little bit about his technology because it's really cool stuff. Thought you guys might be interested. Go ahead, Bob. Tell us about your motor and about specifically about your CRF project. I'd like to know a little bit about that.
Okay.
And then tell us a little bit about the motors and just where you're going with your business and why electric.
Okay. Well, the electric motorcycle is actually a good thing to start with. That was my starting point to prove that the batteries were ready. And I was happy to discover that the batteries are ready in terms of the performance. That led me into the design of the BMW. That gave me confidence that that was going to work. My focus was performance, and so the goal was to find the highest power to weight ratio motor and drive system to really fulfill performance in the true sense of the word that competes with gas engine vehicles as well.
So let me talk about maybe the whole companies. So these are the engineering prototypes, and then EVDrive was formed to try to create a whole powertrain family. And what we tried to do is establish a range from the first engineering prototype Bob engineered with his team, from the motorcycle all the way up to BMW and beyond. And what we're showing today at SEMA is that whole range of products, from 65 horsepower up to potentially 940 or more horsepower.
Okay, so why don't you go ahead and tell me, let's go engine by engine. You can tell me about each one.
This one right here is actually was designed explicitly for a motorcycle drive system and equivalently as a generator for a range extender in the cars. And it is truly a very compact power unit that can deliver in this form 80 horsepower worth of output power. Peak continuous is actually very close to that because it's liquid cooled. And this, by the way, every motor we do is liquid cooled only by oil with a water heat exchanger, typically to use normal cooling system.
This is configured here for oil direct, but right here shows a water heat exchanger that can be attached to this configuration, so you have an external water loop.
That's right. So the point is to use the resources of a vehicle in the most efficient way, and water cooling is better than the oil direct. So this fits that application perfect. So we've got this custom design now in 2 vehicles right now, proving their worth, and I'm happy to say they are performing flawlessly. And very impressive performance. My BMW has increased its performance quite significantly, going from the original gas engine with a peak of 185 horsepower to this motor with a peak of 200 horsepower. But the torque is where the difference really lies, where this has full torque from 0 to 5,000 RPM, and which makes it significantly more performance than the gas engine. In any case, even if the peak horsepower were the same. So this makes a very, very good and fun package to drive the car with.
And you can look at the build library on our site, evdrive.com, and you'll see the engineering prototype going together for that installation. But that's not with this motor. That's with the off-the-shelf components that validated the concept.
That's right. The original prototype started life in 2008 with a AC induction motor from Siemens that I used a 100 kilowatt drive that was producing 132 horsepower, and that just about 3 months ago we switched to this motor, and now I've got about 2,000 miles logged on this motor, and it increased the performance 50%, so now I'm well over the original performance. So now a week ago we got this motor put together, and this takes a huge leap forward in performance, where this has the ability with a 650 volt or above battery system can deliver 470 horsepower. So now we're touching...
What was that?
470 horsepower.
Thank you.
Real power. This is the
that's
kind that can replace a V8.
And at 0 RPM, we're talking about 305 foot-pounds of torque, 0 RPM. So this is a big improvement, because look at the size of that package. I mean,
this electric crate motor essentially replaces a V8 solidly.
And what can you do to this? You spoke a little bit about a dual core. What is that?
Let's talk about that.
Okay, so the dual core, we can take either of these motors and extend the body with 2 internal cores and literally have two two inverters driving them and double the torque and the horsepower.
So we're talking about 940 horsepower and 610 foot-pounds of torque at 0 RPM.
With a motor that weighs about 160 pounds in total.
That's the double? Is that
That's
the
the
double?
double.
Wanna
That's
make
the
sure.
double.
Now let's talk about the double of our smaller guy.
So this one right here can also be doubled with a core, sharing the same shaft and oil pump resources, and get a 400 horsepower peak out of that.
And that would be a 472 foot-pounds at 0. 472 at 0 RPM.
That's
pretty
right.
incredible.
Another
like
increment, we can take this motor in a single form and bump the voltage from 350 volt environment, like we currently are using in both vehicles, to a 650 or greater voltage pack and double the horsepower with the torque staying the same.
so that'd be
with the same motor, all you're doing is dumping more voltage into it
Right.
and increasing the power.
The horsepower, but the torque would be the same.
Torque's the same.
It's actually the same.
So again, going to the dual core will double both the power and torque.
So did we talk enough about this little guy? I think we did. Range extender application?
No, we didn't touch that yet.
No, let's
so
talk
this
about
one
it.
actually has the benefit of being both a motor. Well, all of these can be both a motor and generators equivalently. In this case, we're using this for the range extender in the cars to allow driving past the end of the battery pack range. So you can drive across the country with fuel with this. Of course, with the bulk of the driving normally done with pure electric, so that the use very little gas. But this prevents you from the range anxiety problem right here. This can be scaled 2x larger or
Slightly
2x smaller. And scale into all sorts of different applications as well with the same efficiency. The efficiency on this is a PMAC motor, a permanent magnet AC design, that is one of those highest efficient designs right now available, 96% efficient motor. These ones are also very good at 95%, but this PMAC motor is even higher percent.
We also like this motor because we have an exclusive relationship with the trade secret owner of this motor, so we really control the intellectual property. The nice part is, as Bob was just saying, there's certain frame rails in power sports, motorcycles and quads, that put a limitation, like the CRF, the Honda CRF 250. So we need that. We need to be able to scale it down. This motor, we have a limit because the core we get from a third party. They're not going to make a new core just for us. This, we control that, and we can make these very narrow.
Any voltage, any torque by the depth of the lamp stack. So quite variable with this.
So we see this as the future of power sport conversions.
Yep.
And then how about gearing down? Talk a little bit about that.
Okay, so we've got a number of options. I guess.
I mean, we're talking about running at 12,000 RPM.
Yep.
That's kind of high for a lot of applications.
So if you wanted to actually use this as a drive motor, then you would definitely want to gear this down to utilize the full RPM range. And we can do this in a number of ways. In a vehicle, for example, as opposed to a motorcycle, we can extend the face of this with a planetary gear reduction and get the gear reduction to the point we can drive a wheel direct. We can put one on each of four corners of a car, or put just two in the back and have a 160 horsepower drive system.
And that would be electrically shiftable, so a high-low range electric solenoid basically actuates a sun gear and moves it into different locations.
That's right. So we can either do a single gear reduction that's about maybe this much longer body length, or go about this much longer and have a two-speed planetary gear reduction.
Very good. Very good.
And obviously, when you reduce, you multiply the torque. So, look at 48 foot-pounds through a 2-to-1. It's about 100 foot-pounds through a 3-to-1, 150. You can do the math.
All right.
So you're getting out amazing power density out of those.
Absolutely. Now, the same thing applies to both of these motors as well for gear reduction. We can do the same planetary gear set, a bigger version, but the same. It mounts the same, just extends the face of this essentially, this much or this much, whether we want a single or a dual speed.
Okay.
Either of these motors. So very, very flexible in applications. We could put one of these on each corner of the car as well. If you wanted to have a 1,000 horsepower car, this is how you would do it.
Who wouldn't want a 1,000 horsepower
right.
car?
Be a very efficient machine too, because there'd be no transmission, no differential needed. This would have the power that you don't need gears in necessarily, but if you wanted them, you can still put in the two-speed gear reduction.
And all your stability controls, all software. You can pick your mode. Drift mode, which is equal torque to all wheels. You can pick a traction stability control, which the minute one wheel is sensed that its current is falling, meaning it's spinning, then you
back off the power.
Back off the power just to that wheel. You can pick any mode. You can have people hack and create their own modes. It's really quite a opportunity if you can do that.
Another point about these, of course, I mentioned there are both motors and generators. The normal use of this is regen is a significant part of the driving cycle now. All the stopping can be done with complete regen power and actually get some power back in your battery pack and save your brake discs. So the brake pads will essentially last much longer now. In the applications that we have here and the BMW, we have this hooked up to the original transmission. We're using the original clutch system, so it's all still functional. So that you can quick change gears while in motion using the clutch. When you come to a stop, you don't need to push the clutch. You simply just let off the pedal, come to a stop, and it turns into an automatic, but still it's a manual. If you want to start off in second gear, no problem. You got so much torque, you just press on the pedal and it's an automatic from 0 to about 80 miles an hour. If you want a little bit bigger range, automatic, you start off in third gear. It's a little more gentle off the line, 0 to 130 mile an hour range in third gear. There's still 2 gears left. We believe that this motor in this chassis and the BMW will hit about 150 miles an hour with a 200 horsepower motor.
Nice. Well, that's great. Is there anything else you want to add about your motors and or about EV technology in general, or about your own experience with EVs?
Another interesting point about all this stuff is, and I'm demonstrating this, I'm actually driving with my own power. I make all the power I drive annually with a solar array that's mounted on my roof at the home, grid tied, so it's hands off, no maintenance of any kind. The power goes onto the grid during the day, where the power company is legally required to pay me full on-peak rate and mid-peak. It's a little combination of mid-peak and on-peak, full-peak rates. And I take my power off the grid late at night at half the cost. So I'm actually making 1.7 cents per mile driving my BMW now, and have an improved performance ride at the same time. So it became a very cheap car to operate. In fact, the only wear and only service is tires on the car.
Oh, that's great. And that's solar power in Oregon.
That's solar power in Oregon. I have 15,000 miles of energy off of my panel in Portland every year.
We're not talking Arizona. We're not talking about Texas. We're not talking about sunshiny Florida. We're talking about solar power in Oregon is enough to drive your vehicle.
And for those that are technical, it's a 5.6 kilowatt array that gives me 4.8 megawatt hours a year, which is equivalent to 15,000 driving miles in my BMW.
Well, that's just fantastic. Well, thank you so much, Bob, for your time and for explaining this. And folks, this is why I'm choosing this motor here to go in my quad to race Pikes Peak with. And we'll see if I find that it's not enough power, we just upgrade to the next one and drop more voltage into it. Thank you, Steve, for your time.
Thank you, Alex.
And
we appreciate
we'll chat later.
All right.
All right.